Hello everyone, welcome back to our channel. So how we used to deploy application in old days. So we have one physical server, we install operating system on it and we install supporting libraries for our application. And on top of it, we used to deploy our application and run the application, right? Basically one physical machine and one application. So this was relationship we used to follow in old days when we used to deploy the application, right? If you can see here, this is one application, one server. This is another application, another server. This is the database and this is the database server, and this is another application and this is another server. So this strategy we used to follow previously. If you deploy application, in this case what happens, if you take one physical server and deploy single application on it, then you might be wasting 80% of your system resources, correct? So to overcome this problem, one application per server, what we did, the concept of virtual machine came in. So we take one physical server and we convert this physical server into multiple VMs. So this is one VM, this is another VM, and on each VM, so on each VMs we deploy one single application. So this is one application on this VM and this is another application on this another VM. Okay. So in this case, what will happen? This is a physical server. So this is a physical server and we installed suppose two VMs on it. So we can install multiple VMs, but here in this case we install two VMs on it, and each VM there would be single application. So in this case, what we are trying to do, we are trying to use the maximum resources of this physical server So now not only one application is deployed on this physical server, there are two different applications running on this physical server, but all do have a boundaries for it. So these are the isolated areas provided for the individual application. So this is one individual application and this is another one individual application. And now two applications are running on it, and we are trying to use as much as physical resources from what, this host operating system or the physical server, as much as possible. But here is one catch. On physical server you install operating system on it. So this is the host operating system, right, on the physical server. Then you install two VMs, correct? And two VMs are there, but each VM have its own individual guest operating system. So this one, right? And on each OS, so this is VM OS and this is another VM OS, and on each OS you will install the dependencies needed for your application, and top of it you will deploy your application. So this is your application, right? So there is also waste of system resources in terms of installing multiple VMs and multiple operating systems on individual VMs, right? So concept of Docker came in. So we take one physical server. So this is one physical server. We install operating system on it, host operating system. Then we install Docker engine. So this is Docker engine. So we install Docker engine on it. Then we run containers on top of Docker engine. So in this case, we are not at all installing the operating system inside the containers. We are not installing the operating system inside the containers, but containers are going to use the kernel of host operating system, the physical server. I mean the resources which are needed, let's say the RAM, hard disks is being used by operating system, those overheads will be removed from the containers. So this container are going to use kernel of physical server. Okay. So in this way, we are trying to use as much as system resources possible. So in this container 1, container 2, container 3, there will be single application which will be having the isolated area. So this is one isolated area of container 1. This is another isolated area of container 2, and this is another isolated area for the container 3. So inside this container, all the files or all the configuration, all the dependencies which we are needed for this application will be isolated inside the container along with the application. So in case of VM, you can see this is the physical infra and it will have its own operating system. This is host operating system, and on top of it you configure the hypervisor. So this is the hypervisor, and you create multiple VMs, and each VM will have its own guest operating system. the dependencies which are needed to running the application and the application itself. So in this case, you can see there are two virtual machines which have their individual operating system on it. But in case of Docker, you will have physical infra, you will install the host operating system, and you will configure Docker engine on it. And on top of Docker engine, you will run the containers, container 1, container 2, and container 3. So basically these containers, we do not have to install the operating system on it. We just have to have Docker engine, and these containers are going to use kernel of the host operating system. So we have avoided installing the OS because the OS also uses the system resources, right? And we don't want to waste those resources in the OS. So in this case, you are saving your space, RAM, processing for needed for this operating system. So as a whole, what is a container? Container is an isolated area of an operating system with resources usage limits applied. So basically when you create a container, you can configure the container to how much RAM, how much processor, and how much other system resources one container can use. So container provides you an isolated area for running your application, and in that isolated area you will have all the dependencies, all the things which are needed to run your application, right? Then what is meant by namespace and C group? So process ID is one namespace, then the network is one namespace, then the file system is one namespace, inter-process communication is one namespace, then the users, this is one namespace. So basically whatever one operating system should have in order to work, all the things they're inside the containers. But the thing is that the container is going to use kernel of host operating system, but still all these things will be there inside the container. There will be user, there will be process ID, there will be network, there will be file system for the container. That's why we called it as an isolated area. Then what is meant by C groups? C groups are nothing but the control groups. So basically we apply the limits on how much RAM, how much processor one container should have. Let's say you have 4 GB of RAM on your physical server, right? And 8 processor on it and 30 GB of hard disks on it. So what you can do when you starting the container, you can apply limit on how much CPU, how much RAM, how much disk one container should occupied. So these are the thing but the control groups. So Docker is like a plugin which activates the namespace and the C groups in Linux. So each container will have its own namespace, and this C group for each container we have applied the limits on how much system resources each container is going to use. So what is the difference between the virtual machines and Docker? So basically virtual machine occupies a lot of memory and space, and Docker container occupies less space. So that we have already discussed, right? So Docker container doesn't have its own operating system, rather it uses a physical server's kernel. So you can see the difference. Each VM runs its own operating system. Then the all containers share the same kernel of the host. So these are the some points. So boot up times is in minutes and container initiates in seconds. So these are the some differences between virtual machines and Docker. So what is meant by Docker? Docker is a tool which used to automate deployment of an application in the form of lightweight containers. So Docker is an open source tool and it is easy to create, deploy and run application using a container. And it package your application along with all its dependencies together in form of container. So if you see the difference in the virtualization and Docker, so there is one physical server, then above it there is hypervisor, and above it there is a multiple VMs. So this is the architecture of virtual machines. And in case of Docker, there is physical server. On top of it, there is a host operating system, and on top of it, there is a Docker engine, right? And on top of it, there are multiple containers. So this is one container, this is another container, and this is another container. So what is meant by virtualization? Virtualization is a technique of splitting physical resources. So technique of splitting physical resources into as many as logical resources. So what is meant by hypervisor? Hypervisor is a piece of software or firmware that creates and run these VMs. Okay. So hypervisor sometimes it's called as a virtual machine manager. So there are two types of hypervisor, type 1 and type 2. So in the type 1, these are the bare metal hypervisors, and the type 2, there are the hosted hypervisors. So on physical server, we just install the hypervisor. So this is the hypervisor, and above hypervisor, we install the virtual machines. One virtual machine, another virtual machine, and this one is third virtual machine. So there are multiple hypervisors like ESXi, then the Xen, Nitro hypervisors. So there are multiple hypervisors are available, and type 2 hypervisors are this one. So first we take one physical server. Above it we install operating system, and above operating system we install the hypervisor, and above hypervisor we just install the VMs. Okay, these are the type 2 hypervisors. So in this case, so there are multiple hypervisors are present. So like Oracle Workbox, then the VMware workstations. So there are multiple hypervisors are available. So what is the difference between type 1 and type 2? So type 1 runs, so this is the physical server and this is hypervisor. So type 1 runs on the physical servers directly, right? It's directly run on the physical server, this one hardware. And in the type 2, we install the operating system first, and above operating system we install hypervisor, and above hypervisor we install the VMs. So Docker is a open source centralized platform designed to create, deploy and run application. And how Docker looks like: first we have a physical server, that is hardware. Above hardware we install the operating system, and above operating system we install the Docker engine first, and above Docker engine we just create the containers. This is one container, second container, and multiple containers we can create here. So hope you understand the concept of Docker, virtual machines, hypervisor, namespaces, and cgroups. Bye bye.